Alright, y'all. Midwest Kim back at it again. Alright, let's get to this. So, my next one I was wanting to work on was the Perkins condensation. In particular, we're making a cinnamic acid using this with a combination of benzaldehyde and acetic anhydride and the presence of potassium acetate, and it's heated to make cinnamic acid and acetic acid. So, I copied this from a paper, and I need to find the paper so I can write my source down in the description. I really just took a couple screenshots of the procedure, and at the time didn't really think about that. So what we're going to be doing here is slightly modified, and what I mean by that is the amounts are all going to be the same, but I'm doing this in a 100 ml Erlenmeyer flask versus a 250 ml round bottom flask. Another part is we are not heating it on an oil bath. I'm going to be heating it directly on a hot plate. So the procedure goes as such: 15 grams or 10.5 grams benzaldehyde, 15 grams acetic anhydride, 6 grams finely powdered potassium acetate is put into a flask with a drying tube. My calcium chloride, my drying tube. It's going to be put on 160 C for 60 minutes, then 170 to 180 for 3 hours. So 60 minutes on the first temp, 3 hours for the sec, and then while still hot, about 90 to 100 C, we're going to pour it into a 500 milliliter flask containing 50 ml of water and fitted for steam distillation. It wants to rinse the flask from one into the second flask. Makes a solution alkaline with saturated solution of sodium bicarbonate and vigorous shaking. Steam distill unreacted benzaldehyde until distillate is clear. Cool and vacuum filter to get rid of unwanted products. Carefully, the filtrate is made acidic with hydrochloric acid, and slowly chill, resulting in solution for cinnamic acid crystals. So, pretty basic. I mean, it's nothing super special, but I just thought it was really cool, as a whole. In the sense, cinnamic acid is the most basic Perkins condensation, I think it was talking about. And so that's what I'm going to be doing. I'm sure this can be done with a few different things, but an aldehyde with the anhydride. So I will, at the very end, talk a little more about the reaction, how it works, all that good stuff. But for now, this is the procedure. Alright, so I've had so much trouble getting set up. And, like the freaking genius that I am, that's a big fucking lie. My aquarium pump is in a block of ice. So, I'm hoping for now, the cold will just maintain this thing till I can get that melted and cooled back down. So, also in here, we got all the ingredients stirring. There's a stir bar that didn't stir, and I didn't really want to take it apart, so I just popped my my dry trap up here, my calcium chloride trap, off, and I threw it down in. So, what we have here is the 10.5 grams of benzaldehyde, 15 grams of acetic anhydride, and 6 grams of finely powdered potassium acetate. Says to put it at 160 degree for an oil bath, and there we go. Probably running a little high. Well, that's okay. It's not making the best contact in the world down there. I'll have to get that fixed. So, anywho, gonna run that for an hour. Oh yeah, absolutely got that up to temp. So run that for an hour. We're gonna crank it up to 170 to 180 for 3 more hours, and then while it's still hot, somewhere around 100 degrees, it's gonna be poured into about 50 ml of water in a 500 ml flask. There we go. Jesus. So we're going to go ahead and run this for an hour. I have had this running for a minute with some heat, and it has changed colors a little bit. Everything was perfectly clear at the beginning, and it's taken on a bit of a... it's not coming up all that great. A yellowy color. And it looks like lemon juice, almost that color. And I have a bunch of potassium acetate stuck to the walls, and that's phenomenal. Because I walked away while my stirrer was at 1,000 RPMs, and it was chucking that up the little condenser there, so it'll get washed down with a little bit of reflux. So as soon as that reflux starts, I'm going to start the counter for the hour, and then 3 at about 20 degrees higher. And we'll come back in an hour when there's really something to report on. And let me just kind of go over, I think vast majority of the people that are going to watch this are familiar with everything, but I've got my dry trap, calcium chloride. It's kind of been packed in a little bit, not too hard, but enough where you can make sure you can get a good drying range. Like here on the end, I did not do as good, but back here I did a lot better. So I love these Stony Lab products. I know Amazon carries them, but so far all the Stony Lab products have been really good, for me at least. And I'm just using a condenser and my 100 ml flat bottom, or not flat bottom, Erlenmeyer, sorry. And this is what we're going to do. The other one says put it in a 500 ml flask and steam distill it until the distillate runs clear, because you're getting rid of the excess benzaldehyde. My potassium acetate had some small clumps in it, so I smashed it back and added an extra 1 ml of acetic anhydride to hopefully maybe drive off a little bit of that water. Acetic acid is going to be produced anyways, so whatever. But I'm hoping that helps out a little bit. And sorry about the shaking. I've had too much coffee today already, so but that's where we're at so far, and we'll come back in an hour and see how it looks. Alright, I don't know how identifiable, probably a little more than it was earlier. There's more of an orange juice color to it, and I've got crap just thrown all over the sides of the Erlenmeyer, and things aren't actually, things aren't actually refluxing yet, but we're starting to get some condensing. I'm gonna guess acetic acid. I don't know. I'm just gonna follow the paper. I mean, something's happening. Let's figure out what. Alright, here we go. So, around 160 degrees. We are 1 hour and after the reflux starts, and the color has darkened quite a bit. It's kind of interesting. Maybe the intermediate, as it forms, the color changes. I'm not sure. Definitely got some good reflux, wiped most of the stuff off the walls, but here we go. We're gonna go ahead and crank it up 20 degrees. There we go. Alright, we're at 180, getting about 160 to 165. So I turned it up to 200 on my hot plate, and we should be getting about 180 in that, somewhere around there. So, thing is plenty cold. That giant block of ice is about gone though, so we're just gonna see where this goes. So cranked it up. That's where we're at right now. Stir bar is still getting knocked around. I kind of think that's funny looking, but all right. Well, let's see how this goes. Calcium chloride trap stayed good. I suck at packing these things. Excuse me. Usually I don't pack them tight enough, so I think I finally did a good job. But I just use rayon fiber cotton, actually, now that I'm talking about that, I use rayon fiber for my vape, to wick my vape with, for anybody who, knows what the shit I'm talking about. So, yeah, we'll come back. It says to heat for another 3 hours at the higher temperature. We'll come back, see what happens. Alright, y'all, I decided to report back like once an hour. It's a 3-hour heating, so I'll do 2, just look at it, and then 1 I'll kind of get switched over. But I got the next step ready. We're going to be using the heating mantle for the next step. Got some nice manganese dioxide staining the bottom there due to my stupidity. So, I just wanted to show that off. I got 50 mils of distilled water. And just set that back there. And the idea here is to take this, and we're going to dump it at about 90 or 100 C still into that water. I believe the reason for keeping it hot and dumping it in is due to the acetic anhydride. If anything is left, it's going to go ahead and hydrolyze that to acetic acid, and take some of the water away. But yeah, I believe that's the reason for it, and a dual reason for that is so we can get to the steam distillation. I hope I'm not being too boring about this, because I'm new. It's all very fascinating to me. I mean, I've been reading about chemistry for years, learning about chemistry for years, never really taught myself how to do things properly, look at things properly, till the last couple years, and I'm a little slow in the head, so I learned slowly, but I think I've got a lot of the basics down now. I'd really like to go to school for this. Ultimately, that's my goal. I'd like to be some kind of chemist doing manufacturing, or maybe a teacher. I'm not real sure. But I love chemistry. It's a big part of my life, and it's amazing. It gives me something to focus on. It's a hobby. So, but go ahead and take a look right here. Come on, focus. Come on, you scumbag. There we go. So, you can still see a little discolored potassium acetate from earlier. I swirled it to get everything off the walls, and I ended up throwing some a little bit up into the condenser, but I figured as it condensed acetic acid that it would start to fix itself. So, and it has. That giant block of ice that was my water for the condenser has kept it cool for an entire hour, and it's still cold. I'm shocked. So, things look okay up here. In here, let's see. We're looking a little more red. You can kind of see some a mild yellow coloration. It kind of reminds me of dichromate, where it's like red, but you can kind of see like a yellowy orangish to it. So, and I wish I could get that other magnetic stir bar out, but apparently it's a piece of crap. I threw it in there, turned it on, and it worked. I put the liquid in there, and it would not stir for the life of me. Cheap freaking stir bars. So, with a lot of these cheap stir bars, I can get 2 high heat experiments out of it. By high heat, I mean maybe 150 to 200 C. They seem to lose their magnetic properties pretty quickly. So I just got a cheap batch with a lot of them in it, and hopefully that'll keep me good for a minute, because I don't want to be spending money on stupid stir bars. Also, apologize if I'm hard to hear. I'm actually wearing headphones, hoping the speaker is picking me up good enough. But we'll see. We'll see. If I sound all mumbly, I'm sorry. So I'm going to try to speak up from now on. Alright, here we are, hour 2 of 180 C. Most of the stuff I washed off. I'm not really sure what's up with that. I didn't get it that far up, so I don't know. But got great reflux right now. Just pouring down the sides. Oh, excuse me. Oh, come on. You piece of garbage. Can you please focus? Damn it. There we go. As you can see, lots of reflux. Not much has changed in the color. Alright, here we are at the next stage. That's what she looks like. I'm going to be dumping this in. I will cut away real quick because I don't have anything to hold the camera, but I'm going to rinse it with 25 mils of hot water. It doesn't say that specifically, it just says rinse. And I'm going to rinse that back into here and we'll come back. Go ahead, I'm going to check this and see if there's any benzaldehyde coming through, and if not, we'll go ahead and filter and I'll come back. Alright, so here we are. This is the resulting solution. It's going to be pretty hot. I didn't find much information on the solubility of sodium cinnamate. So, oops. Come on. Not so bright. Oh, Jesus Christ. Okay, that kind of works. Alright, here we go. So, sorry, it's probably kind of glary. But let's take a look from the top. So, got a bunch of trash in here. And I kind of think some kind of tar or organic impurity of some sort. I'm really sorry, I'm not really good with lighting. Anywho, I don't know what to think of this. I tried to steam distill, and it's pretty much to the point, it's basically clear. I'm not getting any more additional benzaldehyde. I'm not really sure why there's a slight fogginess to what's distilling, but if you look here, that's pretty crystal clear. So I'm gonna say this is done. It's pretty warm. I'm gonna go ahead and filter it here in a moment, and after it cools down a bit, I'm thinking about 14 grams should stay soluble of the sodium salt of cinnamic acid. And yeah, not sure. It's fucking weird, man. Nonetheless, so this is the product. I'm gonna go ahead and filter it. I'm gonna let it cool down a little bit first before going straight into that. But this is the end right here. Let's see if I can. There's some of that manganese dioxide from before, but if you can see, right there's a little layer. Go ahead and pull that up a bit. There we go. It's down there. So, a few milliliters. I'm gonna say I did pretty good on this one, I think. I don't know, we'll find out. I can't get any more to distill over. I've distilled about 200 mils. And I have about 200 mils in this flask. Now, I did set up the three-way distillation head so I could add more water if needed, and I did need it. I think I started with 100 mils, I added 50, and then I added like 75, something like that. I added a little more sodium carbonate solution at the beginning and got a small amount of fizzing, so I know I didn't neutralize it all the way, but hey, pretty close. So I'll go ahead and get this filtered. Got my filter, vacuum filter here, and then my poor vacuum pump over here. I have not been nice to this thing. Actually, I should be ashamed, really. Absolutely horrifying. when I made some diethyl sulfate and sodium ethyl sulfate on the nitroethane escapades I went on. For some reason, I was really determined not to be beat by that one because it kicked my ass a couple times. So I finally got it. Now I don't give two shits about it. I conquered that. And I forgot to change my pump oil, which had some diethyl sulfate in it. And probably, I don't know if sodium ethyl sulfate kind of has a fuming or not. But I get the same thing when I vacuum filter sodium ethyl sulfate. That peppermint smell gets stuck in my vacuum, and I didn't change my oil and didn't have to use it for a little while. So I changed it now. That shit's stuck in there. I don't know what it is. Anybody want to give me some assistance on how to clean that out? Go ahead and help me out. But I will be vacuum filtering my solution here, and yeah, we'll see how this goes. So reporting back, I don't know, man. I think that's all the sodium salt of cinnamic acid right there. Pretty good. It filled up almost the whole flask. Wow. But it's not sodium or potassium acetate. God, man. Carbonate? Sodium carbonate? I don't think so. That's got to be the sodium salt of cinnamic acid. So I think what I'm going to do is filter this, reheat it up, hot filter it. I don't know. I got to think on this one. So after checking the data for sodium carbonate in all its hydrated forms, sodium and potassium acetate, all those should have stayed in solution. It was still quite warm. When it started to crystallize all that stuff out. So I'm thinking it's sodium cinnamate. God, I'm like pretty sure it is. So I'm gonna kind of hot filter it, and I'm gonna heat my porcelain funnel a little bit as it's filtering a little at a time. I don't want to do too much and then it crash out mid filter. So, we will see how that goes. From what I understand, cinnamic acid only dissolves about 0.5 gram per liter, so I could easily double up on what's in here water-wise and only lose about 0.5 gram. So that might be just what I do to keep everything that's in a purity in solution. There's some nice clean cinnamic acid. Alright, here it is. The sodium cinnamate. Finally got it all dissolved. So I gotta go to bed, but we'll continue this later. Alright, you guys. So here we go. This is a continuation from the last one. We got sodium cinnamate, or cinnamate, however the hell you say it. And reach over here. I have the last bottle of muriatic acid. So we're just going to add it until it's acidic, and I'm really probably not going to, I don't know, we'll see. Well, here we go. Let's see if this worked. Yes! Yes! Yeah, it worked. All right. Nice. Yes. All right. That's great. That's great. That worked perfectly. All right. So, oh shit. I thought I broke my pipette. All right. Look at that. That's fucking cool, man. On the other side here, I just have a washed another pipette. So I'm just gonna go ahead and give that a stir. Go ahead and I don't know if you can see that. We got orange, so we're at about a 5, I believe that is. So we're gonna go ahead and throw a little more in. That was dumb. I wanted to see if I could actually smell the cinnamic acid, and smelled the hydrochloric acid. Cool, so what I'm going to do is let this sit, and really, I don't think it's going to sink to the bottom. I don't know. I think it's going to overtake all the liquid. It's just a big solid mass almost. So we'll filter that. We should be, fully acidic. It was a 5, and I added like 3 more mils, so we'll go ahead and filter that, and we'll set up for recrystallization. Alright, cool. So here we go. I vacuum filtered the solid. That's our crude cinnamic acid. We're going to redissolve it, heat it up, and let it slowly cool down. I'm going to wrap it in a bunch of aluminum foil to help hold the heat in so it'll crystallize at a slower pace. So let's go ahead and get that set up. I'll be right back. Alright, let's see. So I've just shut the heat off. As you can see, crystal clear. And I've got this thing coated with aluminum foil to slow the heat loss down to promote bigger crystals. Alright, there we go. So when this cools down, I'll come back. We're going to let it cool down overnight. It's like 10 degrees out here right now, so this should probably work as a freezer overnight as well. Alright, y'all, so we're going to discuss the reaction, how it works, what goes on. The specific mechanism I'm not going to talk about. It's a little long. I wanted to keep this part kind of short because I've kept this video really long already. So it was discovered by William Henry Perkin, and it yields an alpha-beta unsaturated aromatic acid. So as you can see here, the AR being your aromatic structure, your arrow group, your like you got a benzene ring for benzaldehyde. So it's kind of where you're going with that. And then you have an acid anhydride. For my case, I used acetic anhydride. Honestly, I'd like to try this again with propionic anhydride. So just to give it a shot. But you can do this with other anhydrides. And usually the base is the alkali metal salt of the acid anhydride. So if you got acetic anhydride, you do potassium acetate. You can use other bases, but that's just the general, recommendation.
So the way I did it was benzaldehyde and acetic anhydride heated with potassium acetate, and we created cinnamic acid and acetic acid, in which we neutralized all the acids. So you got sodium cinnamate and sodium acetate now in solution, and leftover benzaldehyde. At this point, a vast majority or all of the acetic anhydride is most likely gone, and the benzaldehyde can be steam distilled off without affecting the cinnamic acid at all. Now, once all the benzaldehyde is gone, you can acidify to get your acetic acid and your cinnamic acid. Now, I kind of did this the next day. So when I let this cool down all the way, a bunch of sodium cinnamate crashed out, which was easily resolved by just heating and adding more water till it was gone. Once it cooled down, it didn't crash back out. The cool thing about this reaction is with cinnamic acid is it's so crazily insoluble in water. It's like half of a gram, 500 milligrams per liter. But when you heat it up, a lot of it will dissolve. So my final product actually didn't even make huge crystals. They were fine, fluffy white crystals because I chose water to recrystallize it. If you chose something else like ethanol, you might have better crystal size, but other than that, the crystals are actually fairly pure. I don't think I'm going to do a melting test for this video. I was going to, but cinnamic acid is nothing super crazy to write home about, but this is a really cool reaction. You can actually make something called coumarin with it, and you can take salicylaldehyde and acetic anhydride, and you're going to want to take the sodium salt of salicylaldehyde. It's really hard to say. With sodium acetate, and your byproducts are going to be acetic acid and coumarin. And I thought that was a really interesting reaction. Like, this one actually gets fully cyclized, whereas this one's, the alkyl chain with the unsaturated part to it. I don't know. Anyways, I'm going to go ahead and cut this. This video was a little bit longer than I wanted it to be, but nonetheless, I appreciate you watching this, and subscribe if you want, like if you want, and I'll see you on the next one. Also, before I end this, my bottle weighed 23.17, and with the cinnamic acid was 29.67, and that's with the lid, and that gave me a 6.5 gram yield, which was 44.34%. Average is about 9.5, which is something like 64.8%, I believe it was. But this right here is the final cinnamic acid product. It's fluffy white crystals. It is got a very mild odor. While making it, it gave a strong honey smell. I mean, just ridiculously strong. So, I still put it away a little damp, so my yield calculation is probably a little bit off, but whatever. Anyways, this is the end product. Like I said, I'm going to try it again with propionic acid sometime, and I may try the coumarin synthesis. So, anyways, that's it. That's Perkin condensation.